Hey, do you have a side gig? You know, something that brings in a little extra each month. Well, I do. By day, I'm a product manager for a software team in a bank. But by night, I'm a private investigator. And what is it I investigate? Ruby cases. No, not jewel theft, the programming language. And why did I decide to go into private investigating? Well, there's been rumors of a shady mastermind causing havoc and confusion amongst Ruby developers worldwide with his constant meddling in the source code. I wanted to help put a stop to it. And I decided that I couldn't do this job under my normal name. I needed to protect my identity. And so I chose Deirdre Bug, D for short. Why? Well, for the sole purpose of making this joke. And today I want to tell you about one of my more memorable cases, the case of the missing method. Chapter 1. So I'm sitting alone, bored in my office, my flat, when the doorbell rings, and it's Mike. He doesn't look too happy. Let me tell you a bit more about Mike. He was an acquaintance of mine. We had some mutual friends, saw each other now and again. He was 24 years old, a junior Ruby developer, and he got excited about test-driven development. He'd been applying for an apprenticeship at the prestigious Ruby Institute of Professionals. He managed to get through all of the stages, beating hundreds of applicants to the final stage, and it was happening in 2 days. And there were 2 people left fighting for the last spot, himself and a woman named Jenny. Let me tell you about Jenny. She was 27 years old, also a junior Ruby developer, and she loved all things Rails. She was also Mike's best friend and housemate. They had quit their consulting jobs together to enter the world of tech, and not long after, they also decided to live together. So for the sake of the interview, they'd agreed to work together to prepare so that they each had the best shot. May the best person win, they said. So they'd been asked to research a series of topics which they'd then be grilled on. And one of them was method lookup. And this topic had been assigned to Jenny. But something doesn't add up in Jenny's notes, Mike said. He thinks he spotted a big error, and he's worried that it's going to sabotage their interview chances. But here's the thing, Jenny's been so stressed and panicked, rather uncharacteristically, by this whole process that she won't listen to Mike. She's convinced that she's right and they don't have time for Mike's doubts. You can help me find the answer, Mike said. He said that if I can help him, he'll have what he needs to confidently correct Jenny and save them from interview failure. So he reaches into a satchel that he's brought with him and draws out some sheets of paper. They're Jenny's supposedly flawed notes. I asked him to walk me through them. So Jenny had these boxes to represent the concept of a Ruby object. And all of the objects had a label called class. This was to act as a reference to the parent class of the object in question. So some of the objects were instance objects, and the class label for these referred to another type of Ruby object, a class object. These class objects also had their own class label, and they also had a methods label, which pointed to a table of all the methods that instances of that class could call. And then Jenny had written, any class you define is an instance of a class object called class. So if we were to write class cake in our code, we're creating a class object named cake. It's an instance of another class object. The name of that object is class. Essentially, all classes are of type class, class with a capital C. Then she'd written this code in her notes. So she had a cake class, and there were 2 methods. One was tasty, which returned true if the flavor of the cake was carrot. This made sense to me. And then there was a class method called edible, which always returned true. Then she wrote carrot equals cake.new. And she drew these diagrams. There was a carrot box with its class label. That pointed to a cake box, which also had a class label, and it had a methods label, pointing to a table with tasty. And then there was a class box, and this had its methods label, and it pointed to a table with edible in it. And Jenny had written beside this diagram, a method definition always comes from an object's class. Here, Mike shook his head with frustration. He said it cannot be that the edible method lives on the parent class for all classes. Can I show you something, he asks me. He asks if he can jump on my computer. I agree. He opens up a terminal, enters pry, and loads in the cake class. So he shows me what the class of cake is, and then searches for all of the methods to see if he could find edible. What a mystery. And at this point, I was pretty stumped. I didn't know where to go with this one. But I thought if anyone could solve this mystery, it was Dee. And besides, this meant a lot to Mike. He was prepared to pay me handsomely. And so I agreed to take on the case. Chapter 2. Ever heard of Google? Maybe, if you care about people like me not spying on you, use DuckDuckGo. Well, when I'm Dee, I don't believe in these tools. I don't trust them. It's no coincidence that with this approach, I've become the best Ruby PI the industry has to offer. And so, what did I have? Books. Books, books, and more books. I spent a whole day quickly skimming a load of books, but I couldn't find anything useful. So, I decided to form a hypothesis and go from there. I said, the edible method must be somewhere in the ancestry tree for cake. And so what's the ancestry tree? Well, it shows all of the classes and modules that a class inherits from. So all the possible places that we could find the methods. So I put together this where method. It took an object and a method as parameters, and it searched through all the ancestors of the object's class to find a class where the instance methods of that class, and only that class, included the method that I'd passed in as a parameter. So I went to my terminal, and I created an instance of cake, and then I wanted to check that the method worked. So I said, where is the method tasty in relation to this cake instance? Sure enough, it was on the cake class, and now it was time for the moment of truth. I was sure I'd find the edible method somewhere. What? Nowhere? Nowhere at all? What a mystery. So at this point, I'm a bit confused. And I think that it's time for some fresh air, a change of scenery. So I decide to head to my favorite co-working space. And here I feel at home. I'm surrounded by people hacking away, and I quickly settle down at one desk. And given my naturally inquisitive nature, my eyes couldn't help but stray to the screen of the guy next to me. And I saw that he was playing around in IRB with something called object space. And I asked him, what's that? It looks interesting. He said, well, it's a way that you can interact with all of the live objects within a Ruby session. For example, if you were to type this into your session, then you can see all the live classes that are currently there. So I thought it was time for a break anyway. So why not have a little play in IRB? So I opened up IRB, and I checked all the live classes. 936. So I thought, let me just create a class and see that the number goes up to 937. 938? What? Let me try again and check that this happens again. $940? Why does it keep going up by 2? What a mystery. But I couldn't spend too long thinking about this, because just then my phone rang, and it was my friend wondering where I was. I'd completely forgotten that I'd agreed to go to a tech lecture with her. I was anxious that I didn't have much time to solve Mike's case, but I'd also been cancelling a lot on this friend lately, putting my investigative duties first. So I decided that I should make a little bit of time for her, and I rushed out of the door. Chapter 3. I remember that I turned up just in time for the lectures starting. It was about a language called Smalltalk. I didn't care about this language at all. I only had space in my cold PI heart for Ruby. But as I said, I was there for the sake of my friend. I remember how the lecturer started talking about how Smalltalk was born in 1970, and it led to the birth of object-oriented programming. But it wasn't long before I couldn't concentrate. I just couldn't stop thinking about my play with object space. Each time I created one class, but yet 2 objects were being created. Pay attention, my friend said. So I looked up, and I saw that the lecturer was asking the room, what is the class of a class in Smalltalk? And she had this code on the screen. She'd created a polygon object and had asked, what's the class of it? And it had printed polygon class. And then she asked, well, what's the class of the polygon class? And it returned something called metaclass. The class of a class is called a metaclass, she said. And then she went on to talk about how all of the languages that Smalltalk inspired have their own concept of metaclasses. This included Objective-C, Java, Python, and Ruby. Something clicked. One class, two objects. I made my apologies to my soon-to-be no longer friend, and I rushed out of the door in the direction of home and my beloved terminal. I figured I'd start by trying my luck. But no, of course it wasn't going to be that easy. So I looked for all of the methods on Cake. This was a bit overwhelming, so I thought, why don't I look at all the methods which include the word class? So this was looking easier, and two methods stood out for me, superclass and also singleton class. So the first thing I did was remind myself of the ancestry tree of Cake. Then I thought, let's see what Cake superclass returns. So I knew this wasn't what I was looking for because object was in the previous ancestry tree, and I knew edible didn't live there. So it was time to look at singleton class. Ooh, this was different. I hadn't seen this before. And looking at the ancestry tree, there are a few new objects in there. I was excited. Perhaps I had found the answer. So I went back to my where method and I changed it. Rather than searching the object's class ancestors, I now looked through the ancestry tree for the singleton class. And now it was time for the moment of truth. Result. But I thought, let me just double check that what I think is happening is actually happening. And in my excitement, I forgot how to type. But I got there eventually. And I confirmed that the edible method was on Cake singleton class. Case closed. Chapter 4. So at this point, I was delighted, and I was super excited to share the news with Mike. I also took a moment to wonder whether I should retire, because this case would prove to be my most successful, and they always say that you should quit while you're ahead. But anyway, I gave Mike a call, and the phone rang for what seemed like forever. I was about to lose hope at ever reaching him again, when he finally answered. And I asked if I could come round, because I'd solved the case. He was so excited. He said, of course, come round. I'll have the notes ready and waiting for you. But although I'd solved the case for Mike, I wasn't satisfied. I just discovered a whole new concept in the language that I hadn't heard of before. What are singleton classes? So instead of going directly to Mike's, I took a detour to visit a friend of mine. Her name was Ellen. She's 43, a freelance developer, and she regularly contributed to the Ruby language codebase. She knew everything there is to know about Ruby. Anyway, I proceeded to tell her about the case. And when I'm done, I ask her, so what are these singleton classes all about? She tells me how they're hidden classes created internally behind the scenes, and they're there to hold methods defined for only one particular object. So she said, take your instance carrot of the Cake class. Its singleton class would hold methods only for carrot and not to another instance, say red velvet. So I said, okay, they're working behind the scenes. When does knowing about them become useful? Ellen thought for a while, and then she told me about one of her recent clients. They were called Budgeting Inc., and they were creating a clever artificial intelligence, machine learning, personal finance tool for small business owners. They were expanding globally, and they needed to roll out slightly unique versions of their software for each new city that they entered. Ellen remembers being horrified the first time she looked at the code base. It seems different developers had been responsible for each new city, and they were trying out a different approach for each, naming things differently, testing things differently, designing interfaces differently, so there was lots of duplication. There'd been a lot of wasted time on development because they had been reinventing the wheel each time, often doing a bad job. And this meant that there were lots of bugs. Some things had been copied quickly, other things had been left out. It was difficult in this growing code base to see what was important. So the developers were unhappy because they had a lot of tiresome work and the cognitive load was high. And the product owner was also unhappy because delivery was either very slow or things were spun out quickly and bug-ridden. So Ella wasn't quite sure what to do. And then she tells me how she decided to create a DSL, a domain-specific language. She asked me if I knew what she was talking about. No clue, Ellen, I said. So she beckoned me over to her computer, and she said she wanted to demonstrate a basic version. She opened up a prize session and input this class. It was called City Instance. It had a class method called construct, which took a block. Then she set up a variable called city, which called out to the initialize method. And then she called instance eval, passing in a block. And she said I should pay attention to this line because it would prove to be important later. And then we returned city. We had an attribute reader for taxes. We had an initialize method. We set up a taxes instance variable as an empty array. And then we had a method called tax, which took a name and added that tax to the taxes collection. So let's use this, Ellen said. So she created New York and added some taxes. And now we can easily look at the taxes that New York has. There we have it, Ellen said, a very simple DSL. And we can quickly keep spinning up these city objects. Then she said, imagine if we had other properties, not just taxes, banks, finance schemes. And then imagine if we had more information about each of these properties. So I've just listed a name for these taxes. But what if I also passed in information about rates and different thresholds? Using this simple framework, it wouldn't be hard to extend the city instance class to make incrementally more complex city objects. And imagine taking that to the next level, she said. Imagine interacting with this city instance class in the same way on the command line, but instead of just creating variables in our price session, we're spinning up a new subclass of each city and other related models, taxes, schemes, banks. So Ellen explains to me how this was the sort of thing that she produced for Budgeting Inc., a DSL that allowed for quick and easy scaffolding of each new city class and the related classes. So she said, that's how you create objects of the same type. But what if one of the cities had a quirk? So she said, let's look at something else. So she started creating Bath. She added a tax. And then she asked me to think of something that made people in Bath sad. She didn't like my suggestion, and so she chose something else. And she said, imagine there was something called a rainy day amnesty, and when this happened, the people in Bath didn't have to pay any taxes. So she listed out Bath's taxes. Then she said that the government has decided that it's been raining a lot in Bath, and so let's call an amnesty. Well, hey, no taxes for Bath. Now, remember our friends in New York? They want in on this rainy day amnesty, and so they try and call one. Tough luck. Undefined method, rainy day amnesty for city instance, blah, blah, blah. And what is that? Check this out, Ellen said. And she called singleton class on New York. They're the same thing. So when we enter the realm of DSL and call methods like instance eval, what we're doing is we're leveraging the existence of these singleton classes, because that's where these special methods are stored. So instance eval stores any method passed in via the block in an object singleton class. Let's take a step back to the high level for a moment, Ellen said. So by creating a DSL like this, I enable the developers to easily spin up the new instances effortlessly. She explains to me how she abstracted out all of the key similarities between any city, and now the developers had a frictionless way via the command line of spinning up the foundation for each new city that the company entered. And this led to a better maintained code base, because all of that scaffolding had been well tested and tested once by Ellen. So none of the other developers had to worry about it. They could now focus on the interesting bits, which were the customization required for each new city. So the scope was much more refined. So now the developers were happy, because interacting with this system was a joy. It was easier to have a higher level overview of the whole domain in their head, purely just by looking at the documentation for the DSL. And the product owner was delighted as well, because there were far fewer bugs, delivery was faster, and she could also speak in the same language as the developers, because she could now express new requirements using the terminology of the DSL. And now let's go back to singleton classes, Ellen said. So why are they useful? Well, she said that one of the main reasons she was able to complete the project to a high standard was because she knew exactly where she was defining methods each time. She said, once you enter the world of dynamically creating classes and methods and singletons, the class hierarchy and method lookup gets far more interesting. And she referred to what I'd found in my earlier investigations. So you might be getting error messages, and you need to be able to spot where singleton classes are involved and where they're hiding. And if you can think about it, then it can save you from a lot of headache. And I remember Ellen turned to me with a cheeky smile and she said, so do you know what the class of a singleton class is? I shrugged, no clue, Ellen. So she told me to go away and investigate that for homework, for when I managed to find some time away from my busy PI duties. I never did go back to investigate. But beware, Ellen said. I've been going on and on about DSLs, but they're not the answer to everything. You need to think hard about when you want to go down this route. So if you have complex repeated business rules, and perhaps you need to customize behavior in some specific instances, then consider DSLs as an option, but even then, approach with caution. But you don't even need to be writing them for it to be beneficial for you to understand the basics of how they work. You're using Rails, right? Well, every day you see your DSLs. So she took me to the Rails Guide's website and she said, well, active record migrations, they're carried out via DSL. When you specify which tables you want and the format of the columns, that's all via DSL. When you specify how your Rails app handles HTTP requests, again, DSL. And I'd just been doing this stuff by rote the whole time. I never stopped to think about what was happening behind the scenes every time I typed resources into my config roots.rb file. And there's more, Ellen said. She said that when people talk about Rails magic, it's not really Rails magic. It's just a collection of well-written DSLs. And then Ellen looked at me and said, I hope you're TDDing all of the time. I said, of course. What do you take me for, Ellen? And she said, well, RSpec. The describe, context, it blocks, they're all done via DSL. And so this is why knowing about singleton classes can help, because you might find yourself in a tricky problem. You can't make head or tail of it, particularly if you're inheriting a code base or working on a legacy application. And if you're seeing funny bugs to do with methods, you never know. Singleton classes might be the answer. And having them as part of your suite of debugging tools is useful. So after this conversation, I was feeling super leveled up. And armed with this new knowledge, I headed over to Mike's. But when I arrived, I found a Mike with tears in his eyes. He'd obviously been recently crying a lot, and he couldn't look at me directly. I looked down and I saw that he had crumpled pieces of paper in his hand. They looked exactly the same as the notes of Jenny's that he'd brought me the other day. So I took them from him and looked through them. I couldn't see what was wrong. They looked exactly the same. There was a carrot object with a class label. It pointed to a cake object. It had its class label and a methods table with tasty, and then the class object with a methods table and edible. But wait. It didn't say class like last time. This time it said cake singleton. And as Mike saw me notice this difference, he fell to his knees and broke down in tears. Jenny knew about singleton classes all along. He'd gone into her room to find the method lookup notes in advance of my arrival, and this was the copy he'd found. I, for one, was disappointed in myself. I'd been so focused on the main villain, the shady mastermind, that I'd failed to spot another villain right under my nose. My best friend tried to sabotage me, Mike cried. At this point, he started wailing again, saying he wasn't going to go to the RIP interview tomorrow. Nonsense, you can't give up now, I said. I crouched down next to him, gave him a comforting pat on the shoulder. You can do this. and I have just the thing to help set you apart from Jenny." He looked up hopeful. "Have you heard of DSLs?" I asked him. And I proceeded to tell him everything that Ellen had just shared with me. And although Mike still looked devastated as I left him, I had confidence that I had inspired him with the power of singleton classes, that he'd pull himself together and go and secure that RIP internship. So 2 months later, I managed to drag myself out of my flat and go to a hack night. And I hear a couple of people whispering in the corner. And I look across the room, and who do I see? Ellen. So I walk up to her, and I catch up, and I tell her that I've been reflecting on the case of the missing method, and I had my takeaways. Singleton classes, they're there to hold methods defined for one particular object, and that understanding them opens up this whole new world of Ruby, where you can dynamically create classes and methods on the fly and more complex applications using things like DSLs. But, I said to her, I still feel as if I can get by day to day by ignoring them. So, do I really have to care about them at all? Not really, Ellen said. Like you say, if you're using DSLs, then yes, you really should know what you're doing. And they do underpin popular frameworks like Rails. But day to day, you can get by. However, she said, understanding why singleton classes are there and how they work is super interesting and empowering. Think of the Ruby core team. They wanted to keep things as straightforward and as simple as possible. And by simple, I mean minimize special cases. Aim for having one way or one pattern for explaining how anything works, wherever possible. How consistent can we get things, they asked. If you think about methods in Ruby, they're all defined in one of two places, a normal class object or a singleton class. So if you think about it, every method in Ruby is really an instance method, because class methods don't have any fundamentally different behavior. What we call class methods are really instance methods where the object in question is a class and the method is stored on the class's singleton. It's a key foundation to how the Ruby object model works. So yeah, singleton classes are invisible and you can ignore them, but they are in fact everywhere. They're a fundamental part to how Ruby works. So I left the hack night deep in thought. Ellen had inspired me to explore more of Ruby behind the scenes, because there was so much here that I didn't know. I had only scratched the surface. I'd always been a general Ruby PI, and I'd been very successful in the field. But perhaps it was time to find a niche and reach the next level.